Hello again. This is the third video in our tutorial series. In this video, I will guide you through the tool's parameters and using the tool to conduct an analysis for a case study region, the Mekong River. This video will cover parameterizing the tool manually using the tool's interface, as well as alternative methods for loading default settings and using a config file to quickly populate the tool's parameters. So let's get started. We'll need to access the tool like we had done in our first video in this series. So as a refresher, we can go to the catalog menu here, expand the home directory, and if we're using the input MXD ArcMap document, we should have access to the tool in our home directory here. Alternatively, if you've established a folder connection to the file folder containing the tool, you'll be able to access it through folder connections. There's also the Arc Toolbox menu button you can press here to open the Arc Toolbox. It can also be opened through the Geoprocessing tab and selecting Arc Toolbox. In our first video, we added the Free-Flowing Rivers Analysis Toolbox to the Arc Toolbox, and so we should have access to it here. And we simply expand the toolbox and double-click on the tool to open it. So now that we have the tool open, there are three ways in which we can parameterize the tool. We can go through each of these settings manually, which I will cover later on in this video. We also have the option of loading default settings. So if we check this button here, the tool is populated with default settings. And so this is the fastest way to get the tool running if you just want to get it running, make sure it works, that sort of thing. You check this button and then press OK. And the tool is ready to start processing the data. Another option for adding parameters to the tool automatically is to use a config file. So a config file is produced whenever the tool creates results. The config file is an Excel workbook that saves the parameters that were used for that run of the tool, and it's a way of documenting the parameters of the tool. And it can also be used if you'd like to rerun those analyses. So you can select this button here, which will open the File Explorer, and you can navigate to a config file of a previous run, and that will populate the parameters with those settings. The intention here is that you can then make minor modifications to an analysis or redo an analysis that you've previously done. In our example data, we provide a tutorial config file as an example. So if we go here, we can then navigate to the data folder and where the example data is contained, as well as the tutorial config. If we select open, the tool's parameters will be added, and there's a little message here saying that the parameters were auto-populated using a config file, and that we should ensure their accuracy. If you do use the tutorial config file, it won't work right away, simply because the path settings haven't been set, because these will be different on your machine than they are on mine or any machine. And so if you want to use the tutorial config file, you need to specify the file paths for these settings, and then everything else should work because all the other parameters have been set. Okay, so with that, those are the options for parameterizing the tools. And now I'll go through what each parameter means, and we'll specify them manually before conducting an analysis. So let's open the tool again. We'll start with the run options. So here we have 4 options, and these indicate the calculations that the tool will conduct. So we can specify any number of these that we wish. These first 3 options here are used in calculating the CSI, and these values are stored in our streams feature class. And we have the option to either overwrite these values or use pre-existing values. And if we're using pre-existing values, we don't necessarily have to run these first 3 in order to calculate CSI. But since this is the first run of the tool, we're going to calculate all 4 to make sure we overwrite the pre-existing values and create new values that we're going to use for our CSI calculations. Next, we have our path settings. And so these are settings that indicate where, or tell the tool where the input data is and where we'd like to save the output data. So we'll just click this button here and navigate to either our home directory or the folder connection we've established to the data. And we'll add the pre-existing data to each of these paths. So for the barriers, we will select barriers. For benchmarks, we'll select benchmark. For streams, select streams. Lakes. And then for our output folder, we'll navigate up a folder and select output, which is that empty folder I discussed in the previous video. So now we have general settings. So these settings here apply to a few of the different calculations the tool conducts. This first setting here is a field in the barriers feature class with values of 0s and 1s and indicates whether to include that barrier in the analysis or to exclude it. And so values of 1 would indicate, yes, I want to include this barrier in the calculations, and values of 0 indicate to ignore that barrier. And so there's a few different examples here of an inclusion field. We'll just go with the first one for now. Next we have the update/overwrite stream table. And so when we calculate any of these first three options for the run options, these values are stored in our streams feature class. And so if we want to overwrite those values and make new values, we would select yes here. If we want to use pre-existing values, we can select no, and then we won't alter those values. But since this is the first run of our tool, we want to create new values, we're going to select yes. Next we have the minimum length threshold. And so this specifies a threshold, and rivers below this length threshold will be excluded from certain statistics. For our tutorial here, we're going to select a value of 100, and just as a reminder, this length is in units of kilometers, so this means that streams less than 100 kilometers will not be included in certain statistics. Next we have our degree of fragmentation settings, and so these relate to the run option of DOF for degree of fragmentation. And so here we specify the field in the streams feature class where we want to store or use the values for degree of fragmentation. And next we have this option here, which allows us to specify whether we want to use a discharge range factor that is specific to each dam, or use a static value that is applied to all the dams. So if we select yes, if we select no, we want to apply a static value, and so this means each dam will receive the same value for both upstream discharge range factor and downstream discharge range factor. These values here have to be greater than or equal to 1. There's no upper limit to the maximum number you could set, but it's not recommended to have a value greater than 10. And the default value here is 5. Same for the downstream discharge range factor. Alternatively, you could set this to yes, which means that for each barrier you want to specify a different discharge range factor, and those would be specified in the attribute table of the barriers feature class. So in that attribute table, each row represents one barrier, and you could add a column to indicate which values you want to apply for that barrier for the upstream discharge range factor, and a different field for the downstream discharge range factor. So in the example data, we have the DRF up and DRF down. But for the purposes of this tutorial, we're going to set this setting to no. And we'll just use the static default values of 5. Next, we have degree of regulation settings, which affect the degree of regulation calculations. So first we specify which field in the streams feature class we want to store our degree of regulation values. And then we select the source field for our reservoir storage volume. So we have the field STORM, here it is, STOR for storage, and then we have MCM, which is the means it's the units, it's a million cubic meters. And sorry, I think I said this was in the streams feature class, this is in the barriers feature class. If you use your own values, make sure that they are in the units of million cubic meters. Next we have our sediment trapping index settings, which correspond to the SED calculations. And so for this, we simply just specify which field we would like to store our sediment trapping index calculations in. And then lastly, we have the scenario table. So this is the settings we apply for our CSI calculations. So first we have to enter a scenario name. There's a few different restrictions for this, like it can't start with a number or an underscore, and it can't contain special characters, and it has to be under 10 characters. These rules are explained in the documentation and also the help menu here. And if you do enter an invalid one, an error will be generated. You can correct it. So once we add that, we can then expand our tool to look at some of these other options here. So we have our degree of fragmentation indicator, which this drop down here provides the list of fields from our streams feature class. And so we're simply selecting the field in which our degree of fragmentation values are stored in, so DOF. Same thing for degree of regulation and sediment trapping index. We also have 3 additional indicators for water utilization or water use. We have road density, and then we have urbanization as well. So those are the 6 indicators that are used in calculating the connectivity status index. Next, we can specify weights for these indicators. So if we want to put more of a weighting on certain indicators over others. And so there's 6 weightings corresponding to each of the indicators. And these values here must sum to 100. So I'm just going to put in some numbers here. So in this case, the degree of fragmentation and degree of regulation values are weighted more heavily than the sediment trapping index and water utilization, and then road density and urbanization are weighted the least. Next we have our CSI threshold, and this is the threshold which is used in determining the free-flowing river status, and this value is typically set to 95. Next we have our floodplain weighting, which has interactions with our road density and urbanization indicators in floodplain areas. And for this, we're going to set a value of 50. Next, we have our filter threshold. This is used in filtering out extreme outliers, and it's recommended to set this value to 0.1. Next, we have to process. So this is a yes or no option, and simply indicates whether you want to process this scenario with yes or no, skip over this scenario. So we could have a series of scenarios in our list here, and we could skip over some of them by selecting no. Lastly, we have the to export, and this is whether we want to create the output data for this scenario. And since this is our only scenario, we of course want to create the output data for this. But again, if you had many scenarios and you wanted to skip over 1 or 2, you could set it to no and not create results for those. Okay, so with that, the tool has been parameterized. Now we just press OK, and the tool will begin to run. We'll bring this over to the center of our screen. I recommend unchecking this if it is checked, and that will leave the dialog window here open when the tool is finished running. And that way you can examine any of the messages that have been printed out. So while the tool is running, it will indicate which section it's running. So right now it's calculating the degree of fragmentation settings, and there's some helpful information here about its progress through those different calculations. Now it's moving on to run degree of regulation. And so we're just going to wait for it to process, and then I'll talk a bit more. Okay, so now the tool's done. It automatically opens the results. So here's the results spreadsheet, which contains some of the statistics from the tool. I will go over this in our next video. We also have an output ArcMap document that visualizes some of the output map results. Again, this will be covered in a future video. And so once the tool's done, it'll have a message here saying that it was completed and that it succeeded, and provided a timestamp for how long it took to run. So that's the end of this video. We covered how to input the different parameters for the tools and what options are available for inputting tool parameters, and we conducted our first analysis. In our next video, I'll go over some of the output results from this analysis.